Okay, let's see how you did on problem 14. In how many ways can you arrange the numbers 4, 5, 6, and 7 to make a 4-digit number? List the permutations. So let's go ahead and imagine that we started with a 4 first. So we start with a 4. Well, how many other numbers or options could there be? Well, this would be the first number. This would be the second, the third, and then the fourth. Okay? So, if 4 is the first number listed, for the second number, you could either have a 5, a 6, or a 7. Okay? Those are the options. Now, if you had a 4 first and then a 5 second, for third, you would have two options. You would have either a 6 or a 7. Okay? And then from that, it would be 4, 5, 6. It would have to be 7 in the fourth spot. And this one would be 4, 5, 7. It would have to be a 6 in this spot right there. Okay? So if we move over here, if we go 4 first and then 6, 7, 6 second, for the third spot, we would have two options again. We would have 4 and 6, so it would be 5 and 7, which would mean for the fourth spot, we would have 4, 6, 5. It would have to be 7 here, and this would be 4, 6, 7. It would have to be 5 there. Okay? Now let's move over here. For if we roll a 4 first and a 7 second, then in the third we'd have two options. We would either have 5 or 6, which would mean for the fourth spot for this one, if we have 4, 7, 5, this would have to be 6. And for this one here, 4, 7, 6, 5. So we have quite a few options here. So let's go ahead and list them. We first have 4, 5, 6, 7. 4, 5, 6, 7. That would be one option. Another option would be, so this one is done. Another option would be 4, 5, 7, 6. 4, 5, 7, 6. And now that option's done. And then 4, 6, 5, 7. 4, 6, 5, 7. That option's done. And then 4, 6, 7, 5. And this option's done. And then we have 4, 7, 5, 6. 4, 7, 5, 6. And 4, 7, 6, 5. 4, 7, 6, 5. So those are all the options for this particular, if 4 is first. But there could be a different number first. We could have 5. 5 could be first. So let's say 5 is first. Well, if 5 is first, that means in second place we could have 4, we could have 4, we could have 6, or we could have 7. Okay, in second. So if we go with 5 and 4 in third place, we could have two options. It could be either 6 or 7, which would mean that fourth option would have to be, if we have 5, 4, 6, this would have to be 7. And this would be 5, 4, 7, this would have to be 6. Okay, if we go to 5 and then 6, 5 for first, 6 for second. For third, we would have two options, which would be 4 or 7. And then for fourth place, if we go 5, 6, 4, it would have to be 7. Or 5, 6, 7, this would have to be 4. And then the other option here, 5 first, 7 second. we would have two options again. We would have 4 and 6, which would mean that fourth option would have to be 5, 7, 4, 6, or 5, 7, 6, 4. Now we can list all of these options. We would have, one would be 5, 4, 6, 7, 5, 5, 5, 4, 6, 7. Now that one's done. Or 5, 4, 7, 6, 5, 4, 7, 6. Or 5, 6, 4, 7, 5, 6, 4, 7. Or 5, 6, 7, 4, 5, 6, 7, 4. Or 5, 7, 4, 6, 5, 7, 4, 6. Or 5, 7, 6, 4, 5, 7, 6, 4. Okay, so those are all the options if 4 is in first or if 5 is in first. But we have another one. We could have 6 in first. So 6 could be in first, which means the options for being in second would be 4, 5, or 7. So if 6 is in first and 4 is in second, the two options for third would be either 5 or 7, which would mean that for fourth place, this would have to be 7, 6, 4, 5, 7, and for fourth place over here, 6, 4, 7, this would have to be 5. Okay. Now if we went 6, 5, the other two, it would have to be 4 and 7, which would mean in fourth place, 6, 5, 4, this would have to be 7, and 6, 5, 7, this would have to be 4. Okay, and then this last one here, if 6 is in first and 7 is in second, there would be two options for third, which would be 4 and 5, which would mean for fourth place, and this one, 6, 7, 4 would have to be 5, and 6, 7, 5, this would have to be 4. So now we can write down the options. First one would be 6, 4, 5, 7. So 6, 4, 5, 7. Then we'd have 6, 4, 7, 5. So 6, 4, 7, 5 would be here. And then we'd have 6, 5, 4, 7. 6, 5, 4, 7. And 6, 5, 7, 4. 6, 5, 7, 4. And then 6, 7, 4, 5. 6, 7, 4, 5. And then 6, 7, 5, 4. 6, 7, 5, 4. Okay. Now the only other option left for first place would be 7. If 7 was in first. So we need to go ahead and create all those options. So if 7 is in first place, that means that in second place there's 3 options. It could be 4, 5, or 6. And if we have 7 in first and 4 in second, then there's 2 options for third, which would be 5 or 6, which for this one, if we go 7, 4, 5, in fourth place, it would have to be 6. And for this other option, 7, 4, 6, the fourth place would have to be 5. Now, if 7's first and 5 is second, there's 2 options for third, and it would have to be 4 and 6. And if it's 7, 5, 4, this would have to be 6th in fourth place. And if it was 7, 5, 6, then it would have to be 4 in fourth place. And then we go to the 6. So if we roll a 7 first and a 6 second, we have 2 options for third. We have 4 and we have 5, which means the fourth place would have to be 7, 6, 4, 5. And then for fourth place here, 7, 6, 5, 4. And then we can write all the options. So the first one would be 7, 4, 5, 6. So 7, 4, 5, 6, followed by 7, 4, 6, 5, 7, 4, 6, 5, and then we would have 7, 5, 4, 6, 7, 5, 4, 6, and then 7, 5, 6, 4, 7, 5, 6, 4, followed by 7, 6, 4, 5, 7, 6, 4, 5, and then 7, 6, 5, 4, 7, 6, 5, 4. Holy goodness, that is it. Those are all those. That is a list of all the permutations. That was a lot of permutations. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Wow. So that would be 24 different ways. 24 permutations. It says, in how many ways can you arrange the numbers 4, 5, 6, 7 to make a 4-digit number? It would be 24 ways. And we could do the multiplication if we had, you know, we can show that too. So this is the first number, the second, the third, and the fourth. Well, there are 4 numbers, so there's 4 options for first place. There's going to be 1 number here, which means there's only going to be 3 options for second. There's going to be a number here and a number here, which means there's only 2 options for third. And there's 3 numbers in these spots, so there's only 1 spot left over. So if we go 4 times 3 is 12, 12 times 2 times 1 is actually equal to 24. So yeah, there you go on that one. If you got that one right, awesome job. That was a lot. Okay, 15 says, find the number of permutations of the letters in the word for. Okay, so find the number of permutations of the letters in the word for. Okay, so we're going to have a first letter, second letter, third letter, and fourth letter. First, second, third, and fourth. Okay, so how many options can be the first letter be? Well, there's 4 letters, 1, 2, 3, 4, so any of those 4 could be in the first spot. So we're going to be 4. In the second spot, we know that one of the letters are going to be here, so there's only going to be 3 left over that could be in the second spot. In the third spot, there's a letter here and a letter here, which means there's only 2 letters that can be left over. And then for the fourth spot, there's 3 letters holding these spots, so there's only 1 letter left over. So if we just multiply these numbers, 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 1. We get 24 permutations. All right. Okay, cool. Yeah, so let's go on to the next page. All right. So I want you to go ahead and try these problems on your own. So go ahead and work on 16, 17, 18, 19, 20, 21, 22, and 23. So go ahead and pause your device. When you get done with those, go ahead and press play, and we'll talk about the problems. All right, see you in a bit. All right, we're back. Let's go ahead and talk about it. Problem 16. In how many ways can you arrange the numbers 3, 4, 5, 6, and 7 to make a 5-digit number? Okay, so we have a 5-digit number. This is the first digit, second, third, fourth, and fifth. First, second, third, fourth, and fifth. So how many, there's 1, 2, 3, 4, 5 numbers here. So how many numbers can go in this first spot? Well, any of those 5. So 5 can go there. What about in the second spot? Well, we know 1's going to be here, so there's only going to be 4 left options there. What about the third spot? Well, there's going to be a letter here and a letter here. So out of 5, there's only 3 letters left that can go there. What about the fourth spot? Well, there's going to be a letter here, a letter here, a letter here. That's 3 letters, which means there's only 2 left over. And in the fifth spot, there's going to be 4 letters here, and we only have 5, so that means there's only 1 letter left that can go in this spot. Then we just multiply all the numbers together, and we end up with, what do we end up with? 5 times 4 is 20. And then 20 times 3 is 60, and 60 times 2 is 120. 120 times 1 is 120. So 120, what's in how many? 120 ways. There we go. If you got that one right, awesome job. Okay, cool. Let's do problem 17. 17 says, find the number of ways you can arrange the letters in the word numbers. Okay, so how many letters are there in the word numbers? There's 1, 2, 3, 4, 5, 6, 7. Okay, so there's going to be a letter here. 1, 2, 3, 4, 5, 6, 7. So first, second, third, fourth, fifth, sixth, and seventh. So in the first letter, any of those letters can go in this first spot, and there's 7 different letters. 1, 2, 3, 4, 5, 6, 7. So any of the 7 can go there. In the second spot, we know one letter is going to be here, so there's only 6 options here. There's going to be 2 letters here, so that means there's 5 left. And then there's 3 letters in these spots, so there's only 4 letters remaining. And then 3, and then 2, and then 1. So we're going to multiply all these together. And we end up with, what do we end up with? 7 times 6 is 42, right? Okay, so this is 42. And 7 times 6 is 42. And then, oh, I shouldn't put it right there. Why did I put it right there? Okay, it's 42 here. I shouldn't put it there either. I'll put it over here. 42. So 7 times 6 is 42, and then 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So we'll just go 42 times 120. So 2 times 0 is 0. 2 times 2 is 4. 2 times 1 is 2. I'm in the 10, so I need to put a 0 on the ones. 4 times 0 is 0. 4 times 2 is 8. 4 times 1 is 4. Then I add. 0 plus 0 is 0. 4 plus 0 is 4. 2 plus 8 is 0. I mean, it's 10. It's 10. Write the 0, carry the 1. 1 plus 4 is 5. So there you have it. There are 5,040 different ways to arrange the letters in the word numbers. Okay, cool. Problem 18 says, what is another way of showing 5 factorial or 5 factorial? And I think another way of showing it is just 5 times 4 times 3 times 2 times 1. That is another way of showing it. That is what 5 factorial is. We can look up here. 5 factorial is the same thing as equal to 120. But I think they're looking at this. They're saying, hey, write it all out. Okay, let's look at problem 19. Problem 19 says, how many permutations of the numbers 10 through 14 are there? Okay, so 10 through 14. So how many numbers are there between 10 and 14? So there's 10, which would be 1, 11, which would be 2, 10, 11, 12, 13, 14. Okay, so there's 10, okay, there's 10, 11, 12, 13, and 14. Okay, how many permutations of the numbers 10 through 14 are there? All right, so there's 1, 2, 3, 4, 5 numbers. So how many numbers can go in this first spot? Well, any of those 5 can. What about in the next spot? Well, one letter is going to be here, so that means there's only 4 remaining. What about in this spot? Well, 2 letters are here, so there's 3 remaining. What about over here? There's 3 letters here. 3 numbers, I'm sorry, 3 numbers here, so that means that there's 2 left over, and then finally there's 1. And then we multiply them all together, and we know that 5 times 4 times 3 times 2 times 1 is 120, so it equals 120 permutations. So if you got that one right, awesome job. Okay, let's go to problem 20. So problem 20 says, in how many ways can 5 children be matched with 5 puppies? Okay, so we have 5 children. So this is child 1, child 2, child 3, child 4, child 5. These are the child. Child 1, child 2, child 3, child 4, and child 5. Okay, so there's the 5 children. Now, how many puppies could go to the first child? Well, the first child would have 5 options for the puppies. So any of those 5 could go to the first child. Now, this child has a puppy, right? So how many puppies are left as options for the second child? Well, there's only 4 now. And now this child has a puppy. We don't know which one, and it doesn't matter, and that's okay. Well, then we go to the third child. Well, both of these children already have 2 puppies, so that means that there's only 3 puppies left to choose from. Okay, and then for this fourth child, all of these 3 children have a puppy, so now there's only 2 puppies left. And then this last child, they only have 1 option for the puppy. So we just multiply all these numbers together, and 5 times 4 times 3 times 2 times 1 is the same thing as 120. So in how many ways can 5 children be matched with 5 puppies? In 120 different ways. Okay, let's look at problem 21. Problem 21 states 6 friends are waiting in line at the movie theater. And how many different orders can they stand in line? Okay, so theirs would be first, second, third, fourth, fifth, and sixth. First, second, third, fourth, fifth, and sixth. So there's 6 friends. How many of them could be standing in first? Well, any of the 6 could. So that means there's 6 different people that could be in first. How many people could be in second? Well, since one person's in first, there's only 5 people left to be in second. And third, since there's 2 people ahead of them, there's only 4 people left as options here. And then there's only going to be 3, and then 2, and then 1. And then we multiply them all together. And we know that 5 times 4 times 3 times 2 times 1 is equal to 120. So now we know that all that's equal to 120. So all we need to do is multiply 120 times 6. And we get 6 times 0 is 0. 6 times 2 is 12. Carry the 1. 6 times 1 is 6. Plus 1 is 7. So there are 720 different orders. So there we go. Okay. Let's look at problem 22. It says, how many permutations of the numbers 1 through 9 are there? Okay, so 1 through 9. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 9 spots, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And there would be 9 options for this one. 8 options, 7, 6, 5, 4, 3, 2, 1. You multiply them all together. And we end up with, what do we end up with? We end up with, okay, a while ago we did this problem and we found that, I'll put it up. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 362,880 permutations. Okay. And for the last problem, it says, in how many different ways can 7 drivers be matched up with 7 rental cars? All right, so we have 7 drivers. So this is going to be 1 driver. Whoops. This is another driver. 2, 3, 4, 5, 6, 7. Okay? So this is the first, this is driver. And then we have the second driver, third driver, fourth, fifth, sixth, and 7th. So, and how many different ways can 7 drivers be matched up with 7 rental cars? Okay, so the first driver has 7 options for any of the 7 rental cars could go to the first driver. Now, after that, this first driver is going to have a rental car, so that means there's only 6 rental cars left. And then these 2 people are going to have a rental car, which means there's only 5 rental cars left. And then 4, and then 3, and then 2, and then 1. And so then we multiply them all together. And we know that 5 times 4 is, we know that 7 times 6 is 42, right? And, oh, did we just figure that out here? Yeah, we did. 7 times 6 times 5 times 4 times 3 times 2 times 1 is the same thing, which is this, 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same thing as 5,040. So 5,040 matches. And if you got that one right, Yoga Nikki Mashita, you did a great job, and we will see you next time. Goodbye.